Find the critical points of the Lagrange function whose partial derivatives are given by these equations here. So we've got 2x minus 2 minus lambda. That's our derivative of g with respect to x. We've got derivative of g with respect to y and with respect to lambda. So it's 2x minus 2, was it minus lambda? Minus lambda. 2y minus 2 minus 2 lambda, I think it was. And finally, x plus 2y minus 4. Now to find critical points, we have to set all the partial derivatives equal to 0. So this gives us a nice system of equations. We need to try and solve for x, y, and z. Sorry, not x, y, and z, x, y, and lambda that satisfy them. And those are the critical points that we're asked for. Okay, what can we do here? So I noticed that in the first expression, we have an x and a lambda. We could rewrite this. Say 2x is lambda plus 2, and get an expression for x just in terms of lambda. And this is a good strategy if you don't have sort of an immediate gut reaction to anything. Okay, is to solve for some variables in terms of others. This second equation, the derivative of g with respect to y, only has y's and lambdas in them. So we can rearrange and solve for y in terms of lambda. And the last equation, the constraint function, never ever has lambdas in it. Okay, there's only ever one lambda in the Lagrangian. Okay, so what we can do is we can take the x, the y, and plug them in. We will get a single equation in terms of lambda. Now, sometimes that equation is not going to be very nice, and maybe there's other approaches we should be taking, but it doesn't look so bad here. So we've got our x, we've got our y, minus 4 is equal to 0. I'm going to multiply everything by 2, just to get rid of the fractions. So we'll have 4 times lambda plus 1, so that's 4 lambda plus 4. And then 2 times 4, 8. Okay, 2 plus 4 is 6, minus 8 is negative 2. And we've got 5 lambdas. So 5 lambda minus 2 is 0. We can rearrange and say, oh, lambda is 2/5. Okay, now we don't actually need lambda. Okay, lambda's not going to be part of the critical points we are interested in solving for. But now that we've got lambda, we can get x and y. So x was lambda plus 2 all over 2. We just said lambda is 2 over 5 plus 2. Well, we just said lambda is 2 over 5. So we plus 2, we divide by 2. 2 is 10/5. So we'll have 12/5 over 2. Okay, and that's 12 over 10, so that's 6/5. So any critical points we have, x will have to be 6/5. Now y, I think we just saw, was lambda plus 1. This will be the easier one to do. 2/5 plus 1. Well, I suppose we can write it the way we wrote the other one, just to really show off we know where things are coming from. 1 is 5/5, so 2/5 plus 5/5 is 7/5. Okay. So only one critical point. Now, when we're working with Lagrangians, we're going to be doing a constrained optimization question. We really only care about the x's and y's, so you're more than welcome to leave an answer like this. Although if you want to get super technical, you should have the lambda as a coordinate in there as well. Okay. But either or is fine, really.